I will start with problem 8, page 683. 3-point charges lie along a straight line as shown in figure P23.8, where Q1 equals 6 microcoulomb, Q2 equals 1.5 microcoulomb, Q3 equals minus 2 microcoulomb. The separation distances are D1 equals 3 cm, D2 equals 2 cm. Calculate the magnitude and the direction of the net electric force. Net means total on Q1, Q2, and Q3. I'm only going to solve one of them because the three parts are similar. I'm only going to solve part A. Let me first write the given. Q1, it's equal to 6 microcoulomb. You all know how to change from microcoulomb to coulomb. You just multiply by 10 to the power minus 6. So Q1 is 6 microcoulomb. Q2, it's equal to 1.5 microcoulomb. And Q3, it's equal to minus 2 microcoulomb. To know if the charge is positive or negative, you just look at its sign. So it's obvious that Q1 and Q2 are positive, Q3 is negative. The sign is very important when we draw the force because we must know if the other charges are attracting or repelling the charge of study. Given also D1 and D2, we've got D1 equals 3 cm and D2 equals 2 cm. This is the given. So I'm going to start with part A. Part A considers the forces acting on Q1. Who's affecting Q1? For sure, Q2 is acting on Q1 and Q3 is acting on Q1. Q1 never acts on itself. Neighbor charges act on it. So there are two forces acting on Q1. One coming from Q2 and the other coming from Q3. Now the force coming from Q2, how to draw it? أول شي شو بعمل؟ بتطلع بالcharges ال Q1 وال Q2, both of them are positive. So the force exerted by 2 on 1 is a repulsive force. It's drawn along the line joining Q1 Q2 على نفس الخط تاع Q1 Q2 مع repulsion. So it's drawn like this. This is the force exerted by 2 on 1. Now, if I'm going to draw the force exerted by 3 on 1, we look at the signs. For sure, 3 is negative, 1 is positive, so they will attract. So the force exerted by 3 on 1, 3 will attract 1. So it will appear to be like this. So this is force exerted by 3 on 1. So I'm going to solve the force or the net force on Q1, which is the sum of 2 on 1 plus 3 on 1. So this is what I'm going to do. Find F1, which is F2 on 1 plus F3 on 1. هلا أول step دايما بعملها إنه أنا بكتب الفورسز اللي أنا معي إياهم أو الفيكتورز اللي أنا معي إياهم بكتبهم in terms of I and J. Here you see that the three charges are collinear, so I will take x-axis like this. وما رح أحتاج أكتر من x-axis لأنه all of them are along the same axis, which is x-axis. So my forces will be either plus magnitude I or minus magnitude I. Okay, nothing will be along J, nothing will be projected with an angle, so things will be easy here in this problem. So أول step بعملها إنه أنا بكتب الفورسز F2 on 1 and F3 on 1 as vectors وبعدين بجمع. How to write them as vectors? I usually decompose this step of writing a force as a vector into two steps. أول شيء بكتب الماgnitude. I find the magnitude of the force. بعدين بكتبها كvector. Okay, I usually solve like this. So first, let's find F2 on 1 as a magnitude. So F2 on 1, it's equal to K absolute Q1, Q2 over the distance between 1 and 2. بتطلع على الفيجر. Distance between 1 and 2 is D1, so I write D1 squared. Now I will substitute. It's 9 times 10 to the power 9. Q1, it's 6 times 10 to the power minus 6. Q2 is 1.5 times 10 to the power minus 6 divided by D1 is 3 centimeter, which is 0.03 squared, and I get my answer, which is 90 Newton. And this is the answer. Now لقيت الماgnitude. Now I write it as a vector. How to write it as a vector? Simply I look. Is it along I? Is it along J? Does it need projection? هلا هون it appears that it's along x-axis but in the opposite direction, opposite to I. So it will be like this. F2 on 1, it's equal to minus the magnitude F2 on 1 I. It's written like this. And هي ناقص الماgnitude I. It's minus 90I. So now I've arrived to write F2 on 1 as a vector in terms of I. Okay, now I will do the same for F3 on 1. I will try first to find the magnitude, بعدين بكتبها كvector. Okay, we always do the same. So F3 on 1, I first find the magnitude. It's K absolute Q1, Q3 over distance between them, which is D1 plus D2 squared. Remember, it's the distance separating 1 and 3. لأنه أنا عم جيب الفورس exerted by 3 on 1 اللي عم تعملها 3 على الواحد. Okay, so المسافة بين الواحد و3 which is D1 plus D2. It's equal to 9 times 10 to the power 9. Q1 was 6. So 6 times 10 to the power minus 6. Q3 was negative. We remove the minus sign. We're just finding the magnitude. So it will be 2 times 10 to the power minus 6 over the distance separating them, D1 plus D2, which is 5 centimeters. So I will get 0.05 squared. So calculating all of this, I will get 43.2 Newton. Now I've written F3 on 1, this is 3 on 1, as a magnitude. I need to write it as a vector. Go back to the figure, look at F3 on 1. It has the same sense as the x-axis, so it's written as F3 on 1 magnitude I multiplied by I. So the vector F3 on 1, it's equal to F3 on 1 I. No need to project with an angle, anything. It's just with I, with the I vector on I on x-axis. So we will get 43.2 I. Now I have written my two vectors or my two forces as vectors in terms of I. Now I can add them easily. So the force or the net electric force, net electric force on Q1 is F1, which is due to 2 and due to 3. It's force exerted by 2 on 1 plus force exerted by 3 on 1. It's equal to minus 90I plus 43.2 I, which will give me minus 46.8 I. Now this is my answer and this is my force. So if I'm going to draw this force, هلا لو طلب مني ليه الفورس, this can be drawn easily. So look, this is x-axis. Assume this is x-axis and this is my charge, which is Q1. وكان هون عندي Q2 and here I had the Q3. So due to Q2 و Q3, both of them are acting on Q1. The resultant force, مجموع الفورسز تاعون على Q1 is like this, which is minus 46.8. It means that it's a force opposite to x-axis. It has an opposite sense to x-axis, so it's drawn like this. So this is F1, the force exerted on Q1 due to Q2 and Q3. Okay, so لو ال Q1 ما كانت مثبتة وبدها تمشي، في احتمال تمشي, it will follow in the same sense as F1. It will move with F1. This is the total force acting on Q1. Now I won't solve the second parts, which are parts B and C. I will leave them to you, but I will help you find the direction of forces. They are the same, okay, same method. For example, let's start with the Q2. Q2 has forces acting on it due to Q1 و Q3. أول شيء الفورس due to Q1 بتطلع على Q1 و Q2. The Q1 و Q2 both of them are positive, so Q1 will repel Q2. Okay, so if I'm going to draw the force on Q2, I'm studying now Q2. Okay, عم شوف الفورسز اللي عم يشتغلوا على Q2 اللي جايين من ال1 ومن ال3. هلا اللي من ال1 هي عبارة عن repulsive force. This repulsive لأنه ال1 وال2 both of them are positive, so force exerted by 1 on 2 will be like this. This is F exerted by 1 on 2. Now force exerted by 3 on 2, force exerted by 3 on 2 هي عبارة عن attractive force. ليه attractive force؟ لأنه 3 و 2 واحدة plus وواحدة minus, so إذا أنا بدي أرسم كيف عم تشتغل 3 عند 2 عم تشد لعندها, so it will be like this. This is the force exerted by 3 on 2. Now فيكم تعملوا مثلي أنا, بتجيبوا الماgnitude F1 on 2, it's the same as the magnitude of F2 on 1. Okay, same magnitude. It will be written as 90I مع ال x-axis. With F3 on 2 you find the magnitude and you write it as function of I. أكيد هي مع ال x-axis. Okay, you add them, you get the total force acting on Q2. Now let's move to Q3. بالنسبة ل Q3, there are two charges acting on Q3, which are Q1 and Q2. If I look at Q1, Q1 is positive while my Q3 is negative. So بالنسبة ل Q3, Q1 is attracting it. So this is the force exerted by 1 on 3. You can see that it is an attractive force. هلا بالنسبة ل 2, ال 2 كمان positive وال Q3 negative كمان Q2 is attracting Q3. So this is the way I draw the force exerted by 2 on 3. كمان هون بلاقي الماجنتيود لل F1 on 3 وبلاقي الماجنتيود لل F2 on 3. بعد ما الاقي الماجنتيود بكتبها ك vector in terms of I, يعني بكتبها هلا هون بالحالتين هي minus I, okay, لأنه بعكس ال x-axis, and you add them and you get your answer. It's similar for what I have already done. So this is for this problem. Now I will move to problem 9, page 683. You can see that before reading the problem that this problem is a little bit different from the previous problem. The charges are not collinear, okay, they are making an angle of 90 degrees. Some of them are along y-axis, some of them are along x-axis. So we will do the same as above, but the resultant force will be different because it will contain both I and J. Okay, 3-point charges are arranged as shown in figure 23.9. Find the magnitude and the direction of the electric force on the particle at the origin. So we're going to find the net force acting on the particle at the origin. So for simplicity, I will call this one, which is 6 nano Coulomb, I will call it Q1. I will call minus 3 nano Coulomb, I will call it Q2, and I will call this 5 nano Coulomb, I will call it as a Q3. Okay, هلا معي distances between ال 1 و 3 وال distance between 2 and 3. اللي طالبه مني هو بالسؤال انه انا الاقي الفورس on 3. أكيد due to mean, due to Q1 and due to Q2. I try to find the force due to Q1, I try to find the force due to Q2, and then I simply add them. Okay, remember they are vectors, we have to find the magnitude, then draw it, then after drawing it, write it as a vector in terms of I and J. So let's start. Remember, we are searching for F3. So the force on 3, on Q3. This force on Q3 is due to the force coming from 1 on 3, and due to the force coming from Q2, which is 2 on 3. طيب تعالوا نبلش بالforce exerted by 1 on 3. Okay, by 1 on 3. Look at Q1 and Q3. Both of them are positive. okay, both of them are positive, so أكيد ال Q1 will repel Q3. لما بدي أرسم أنا ال force exerted by 1 on 3 برسمها على 3 because I'm studying forces on 3. okay, برسمها على 3. هيدي أول شغلة. تاني شغلة, it's always drawn on the line joining Q1 and Q3. okay, so I look at the line joining the two charges Q1 and Q3. على نفس الخط بتبقى ال force, repulsive force. I will draw it like this. So this is the force exerted by 1 on 3. You can see it's a repulsive force. رسمتها. هلا بلاقي الماgnitude بكتبها كفector. okay, so let's find the magnitude. F1 on 3, it's equal to K absolute Q1 Q3 over R squared, distance between 1 and 3. It's equal to 9 times 10 to the power 9. Q1, it was 6 times 10 to the power minus 9. Q3, it was 5 times 10 to the power minus 9. Remember that nano Coulomb is times 10 to the power minus 9. Micro times 10 to the power minus 6. okay, over R, which is the distance separating them. It's 0.3 meter. No need to change unit, so it's 0.3 squared. So calculating this, we will get 3 times 10 to the power minus 6 Newton. okay, I've written the magnitude. Now I try to write it as a vector. I look at it. أنا رسمتها بتطلع فيها. It's along x-axis opposite to the direction of I. So it's written like this. F1 on 3, it's equal to minus F1 on 3I. No need هون ما في angle ما في projection صعب. في along x-axis وبعكس الاتجاه ال x-axis. So it's minus F1 on 3I. Simply it's minus 3 times 10 to the power minus 6I. Now I finished F1 on 3. Now I have to do the same for F2 on 3. okay, أول شي مثل العادي بجيب الماgnitude. So F2 on 3, it's equal to K absolute Q2 Q3. Remember, it's the interaction ما بين 2 و 3. So Q2 Q3, the distance between them, I will call it R squared, equals 9 times 10 to the power 9. The Q2 is 3 nano Coulomb, so 3 times 10 to the power minus 9. Remember, I dropped the minus sign because I'm using just absolute value. And Q3 is 5 times 10 to the power minus 9 over distance separating them is 0.1, so 0.1 squared. Calculating all of this, you will get 1.35 times 10 to the power minus 5 Newton. Okay, great. هلا جبتها كماgnitude. Now I draw it. Remember, after finding the magnitude, you have to draw before writing it as a vector. Okay, I look at Q2 is negative, Q3 is positive. They have different charges, they have opposite charges, so they will attract each other. Remember, I'm finding the force on 3. So the force exerted by 2 on 3 it's drawn at 3. برسمها على 3. It will be an attractive force like this. So this is F exerted by 2 on 3. Okay, so you can see from the figure it's along a J direction, opposite to J. It's along y-axis, opposite to J direction. So it's written like this. F2 on 3 is equal to minus F2 on 3J. It's equal to minus 1.35 times 10 to the power minus 5J. Okay, كتبت ال F2 on 3 as a vector. مش الحال. صار معي F1 on 3 as a vector, F2 on 3 as a vector. Now I can add them in order to find the total force acting on Q3. Okay, so F3 is equal to F1 on 3 plus F2 on 3, it's equal to minus 3 times 10 to the power minus 6i minus 1.35 times 10 to the power minus 5j. Okay, done. I cannot add them because one of them is along I and the other is along j, so they will remain like this. Now he told me to find the magnitude of the resultant force and its direction, so let's find the magnitude. This is a normal force and a normal vectors. To find its magnitude, simply magnitude, so F3 it's equal to radical the x component squared plus y component squared, so it's minus 3 times 10 to the power minus 6 squared, so minus sign will be cancelled when I square the number or the x component and the y component, so minus 1.35 times 10 to the power minus 5 squared. Calculating this, I will get 1.38 times 10 to the power minus 5 Newton. So this is the magnitude of the resultant force. هلا he also asked for the direction. لما يقول direction he means the angle. Okay, الانجل اللي عملتها هيدي الفيكتور او هيدي الفورس مع الاكس axis. So how to find the angle between the force and the x-axis? Simply using the tangent method. So the direction اللي هو tangent theta, okay, it's equal to Fy over Fx. Remember, tangent theta is the angle. Tangent theta is the angle between my force and x-axis. So it's equal to minus 1.35 times 10 to the power minus 5 over minus 3 times 10 to the power minus 6. Okay, so I will get, using your calculators, you have to do shift tangent or arctangent or tangent minus 1, whatever you call it, and you will get theta, which is tangent minus 1 for Fy over Fx. It will give you on your calculator 77.47. In reality ما في بس زاوية واحدة عندها نفس التangent. There are two angles that have the same tangent, the one that's given by your calculator and another one which is equal to 180 plus 77.47. Okay, so I have to choose one of them, one of these angles. I will allow you to see them on the figure. Now let's look at F3, which is the force acting on 3. The force acting on 3 هي مجموع ال 1 on 3 وال 2 on 3. So هي عبارة عن vector. I just complete here this. So هيدي الفورس هيدي هي ال F3. So إذا بدها تمشي ل Q3 رح تمشي مثل اتجاه ال F3. هلا في two vectors they have the same tangent. اوكي، هاي الفيكتور ال F3 والفيكتور الثانية اللي هي opposite معها. إذا أنا برسم بعمل extending لهيدي الفورس ال F3، هيدي اللونة بالأخضر هيدي it has the same tangent as F3. اوكي، so وين ال 77 الانجل طلعت معي 77 هيدي هي this is 77 degree اللي هي هيدي. اوكي، هيدي 77 بس انا الفيكتور تاعيت الزاويه تاعيتها منا 77 مع الاكس اكسس، هي فعليا 180 زائد 77. كيف عرفتها؟ انه هي simply منا بالفيرست كوادرانت. my vector is in the third quadrant من الاكس او واي Cartesian coordinate system. اوكي، سو لو كانت الفيكتور تاعيتي انا موجوده بالفيرست كوادرانت كنت انا اخترت الانجل 77، بس ما انه هي بالثird quadrant I have chosen 77 plus 180 and you can see that the direction of my vector F3 هو عامل زاوية 77 زائد 180. okay, with x-axis. This is the angle, it's called the direction. Okay, some people leave it like in some books they leave it as 77, okay, but they say that this is the 77-degree angle, this one, 77, this one, okay, this is the 77-degree angle. This is in reality 77.47 for sure, بس هي منا مع positive direction of x-axis. I will move now to problem 10. So let's move to problem 10. Same page 683. Two small metallic spheres, each of mass m equals 0.2 gram, are suspended as pendulums by light strings of length L, as shown in figure 23.10. The spheres are given the same electric charge of 7.2 nanocoulomb, and they come to equilibrium when each string is at an angle of theta equals 5 degrees with the vertical. How long are the string? So he's asking me to find the length of the string, which is L. I will write the given. So each sphere has a mass m, which is equal to 0.2 gram. Length L must be found, so we're searching for L. We have the angle theta, which is the angle of equilibrium, which is equal to 5 degrees. We have the charge of both the spheres, Q1, it's equal to Q2, it's equal to Q, if you like, it's equal to 7.2 nanocoulomb. This is the given. To find the length L of the string, I will start from something very important, which is that the spheres are at equilibrium, are both at equilibrium. I will choose one of them. I will choose the one on the left. You can do any one of them, it will give you the same answer. So I'll choose the one on the left and try to find the forces acting on this ball and try to equate them to 0, because according to Newton's first law, the sum of forces acting on each ball will be equal to 0, and I will make benefit of that in order to find the length of the string. Okay, so let's just try to apply Newton's first law. So apply Newton's first law. First, let me draw the forces acting on this sphere, which is at the left. We have the tension. This is the tension. All the time the tension is directed towards the string. We have the weight, which is mg. This is the weight, mg. And because both spheres are charged and they have the same charge, they will repel each other. So same charge, they will repel. And always F is drawn on the line joining the two spheres. يعني أنا بطلع على line joining the two spheres. يا بيكون attractive يا بتكون force repulsive. هون عندي force repulsive برسمها على نفس الخط. Okay, away from the second sphere. لأنه هون عندي أنا repulsive force. So this F is the F from Coulomb's law, which is K absolute Q1 Q2 over a distance squared. As a magnitude. Okay, it's F equals KQ1 Q2 over R squared U12 as a vector. So these are the forces acting on this metallic sphere. So I'm going to add these forces. So tension plus mg plus F is equal to 0. Now you can see that my vectors are not all along x or y. I need to project, so I will take x-axis as usual. This is x-axis, and I will take y-axis upward as usual. Okay, so this is y-axis, and you can see that F, which is the electric force, is opposite to x-axis, يعني مع I. mg along y-axis. Attention, it needs to be separated لأنه هي منا مع الx ولنا مع الy. So I will try to separate it. هلا بما إنه they are identical, for sure here this angle here is theta, similar to this angle. وهون الangle theta, because it's alternating with theta. So now I can find the projection of T. لما بدي أفصل T أنا remember from mechanics T it is decomposed into two components, one along X and one along Y. So when I decompose T, this is the part which is along X and this is the part which is along Y. البارت اللي بيكون adjacent للثيتا دايما بيكون cosine ثيتا والبارت اللي هو بيكون the other one it's always sine. So this one here it's T sine theta, this part here, and this part up I will write it away, a little bit away. I will arrange things. So this part here it's T cosine theta. So and this is T, which is the vector T. Okay, so you can see that the part which is along y-axis is cosine theta simply because it's adjacent with theta, and the other one is sine theta. هيك أنا بكون جهزت حالي للprojection. Now let's write our projection along the x-axis. Projection along x-axis. This will give me T sine theta plus أكيد مع positive axis minus F لأنه بعكس ال x-axis is equal to 0. I will call this one, this is the first equation. Now I will project along y-axis. مين في عندي على y-axis؟ في عندي T cosine theta, a part of T اللي هي T cosine theta والبارت الثاني اللي هو ال mg. So I will get T cosine theta, okay, minus mg, which is equal to 0. I will call this equation 2. Now I will use equation 2 to find T, and then I will insert T in equation 1. You can do whatever you like. You will mix these two equations to solve them. So using equation 2, we will get T equals mg over cosine theta, and now I will use equation 1 to insert this equation. So 1 implies mg over cosine theta times sine theta minus F is equal to 0. So remember, we are searching for length of the string. It doesn't appear yet, it will appear. Okay, so implies F equals mg tangent theta. Now still L does not appear in the equations. Where does it come from? It comes or it appears inside F. Okay, الF تعالوا نجيب الF هيدي الماgnitude. Okay, so الF كmagnitude because when we project we use only magnitudes. We never use نحن algebraic value sign بنحطها برا. يعني أنا بحط minus mg minus F. الساين دايما بتكون برا بالprojection. الأرقام اللي هن الmg T والF هدول magnitudes. Okay, so F is a magnitude. F it's equal to K absolute Q1 Q2 over distance between them squared, so over R squared. هلا Q1 it's equal to Q2. I will call it Q, so it's Q squared. I remove the absolute value because Q squared is positive, and both of them are positive, over R squared, which is equal to, for sure, mg tangent theta. Now الفكرة إنه ال R is related to L. Okay, so let's find R and then we will find L. Let's find R. I will allow you to see how R is related to L. So I will move a little bit down. Okay, so implies R squared is equal to K Q squared over mg tangent theta. هلا I have to relate R to L, okay, because there is a relation between them. I will draw here the figure. كان عندي two identical spheres, they were repelling each other. R هي المسافة ما بين هدول اثنين spheres. Okay, this is the distance between these two spheres. This is R. Okay, theta, it's this angle. This is theta. Okay, وهيدي هي ال. هلا there's an obvious relation between R, L and theta. It's very obvious. Anyways أنا باخد the triangle. This is right angle triangle. The distance هون هي R over 2 the triangle. So this distance here is R over 2. So sine theta, I will write here, but sine theta equals opposite over hypotenuse. So I will get R over 2 over L, which is R over 2L. So I will get R equals 2L sine theta. وهيك بتكون ال بينت معي inside R. Okay, so now I will replace R by its value. Then 4L squared sine squared theta equals K Q squared over mg tangent theta. So L is equal to radical of this quantity, which is KQ squared over 4 mg tangent theta sine squared theta. We've got everything. It's equal to radical 9 times 10 to the power 9. Q was given to be the problem 7.2 nano Coulomb. So 7.2 times 10 to the power minus 9 squared over 4. Mass was given to be 0.2 gram. So 0.2 times 10 to the power minus 3 times 10 times tangent 5 times sine squared 5. So we calculate all of this and we get our answer. Our answer is 0.296, approximately 0.3 meter. Okay, this is for problem 10. Now let's do problem 11. Okay, page 683. This problem says two small beads having positive charges Q1 equals 3Q and Q2 equals Q are fixed at the opposite ends of a horizontal insulating rod of length D equals 1.5 meter. The bead with charge Q1 is at the origin. As shown in figure P23.11, a third small charged bead is free to slide on the rod. At what position X is the third bead in equilibrium? Can the equilibrium be stable? Okay, we're just going to start with part A. Okay, I will write the given. Q1 is 3Q. So Q1 is 3Q. Q2 is Q. And I will call this one Q3. هلا Q3 ما بعرف عنها شيء أبداً. اوكي الا انه هي at equilibrium. ال Q3 ما بعرف عنها انه هي positive, negative. I know nothing. I know that Q1 is positive, Q2 is positive, Q3 I know nothing. Okay, I know that Q3 is away from Q1 by a distance x. Okay, I've got D equals 1.5, so here D is equal to 1.5 meter. So this is the given. In this problem he said that we have to find X if the third bead is in equilibrium. So Q3 is in equilibrium. So I have to start from this point that Q3 is at equilibrium, so the sum of forces, or the force acting on Q3, is equal to 0. Okay, so what are the forces acting, or the sum of forces acting on Q3? What are the forces acting on Q3? The one coming from Q1 and the one coming from Q2. So I find the total force acting on Q3, then I equate it to 0 and try to find the distance, which is x. Okay, so F3, which is the force acting on 3, which is equal to F1 on 3 plus F2 on 3, must be equal to 0 to have Q3 at equilibrium. So what shall we do now? We have to calculate F1 on 3 and F2 on 3, and then try to find x, which is included inside these forces. Let's start first with F1 on 3. F1 on 3 we start all the time with the magnitude. Okay, هلا بالنسبة للسنس نحن ما بنعرف، أنا ما بنعرف التشارج ال Q3، ما بعرف زي بلس أو ماينس، سو أنا ما فين دغري أرسم ال F1 on 3 لأنه هل رح تعمل attraction أو رح تعمل repulsion؟ I don't know. Okay, so I can find the magnitude, but I cannot determine the sense. So F1 on 3, it's equal to K absolute Q1 Q3, because it is the interaction between 1 and 3, okay, over the distance between 1 and 3. The distance between 1 and 3 is x, so it's over x squared. Remember, we are searching for x. Okay, so I will substitute Q1 for its value. Q1 is equal to 3Q. Q1 is positive and 3Q is positive. I can take it outside the absolute value, so I will get K Q1 absolute Q3 like this over x squared. I will substitute Q1 for its value. I will get 3KQ absolute Q3 over x squared. Why didn't I remove a Q3 from the absolute value? Because simply I don't know if it's positive or negative. I will keep it like this. Okay, let's now do the same for force exerted by 2 on 3. The force exerted by Q2 on Q3, it's equal to K absolute Q2 Q3 over the distance between Q2 and Q3. You can see that the distance between Q2 and Q3, this is it, which is equal to d minus x. Okay, so it's d minus x squared. Now I will substitute Q2 for its value. هلا Q2 positive تطلع من absolute value, so Q2 absolute Q3. You can do it as one step. I'm doing it as 2 steps, and I will substitute Q2 with Q, so K Q absolute Q3 over d minus x squared. Now I've got the magnitudes. Okay, now what shall I do? I won't write them as vectors. I will just take the equation above. So we've got F1 on 3 plus F2 on 3 equals 0. This means two vectors, the sum of two vectors is equal to 0. This means that these two vectors, they have the same magnitude, opposite sense. Okay, it can be written like this: F1 on 3 equals minus F2 on 3. I will repeat again. These two forces, they have the same magnitude, opposite sense. So simply, without drawing them, they have the same magnitude. As an absolute value for both sides, we will get F1 on 3, it's equal to F2 on 3. They've got the same magnitude. So implies I've got my magnitudes up. I will substitute for these values. Let me substitute. I will get 3KQ absolute Q3 over x squared equals KQ absolute Q3 over d minus x squared. Now I will remove from both sides K. I will remove Q from both sides. I will remove absolute Q3 from both sides. My equation will get simpler, and we will get, let me arrange a little bit. Now everything is known. I know D, which is 1.5. I can just search for X, which is the point where the sum of forces is equal to 0. We have equilibrium there. Equilibrium means that the charge Q3 will not move. It will remain at rest. Okay? So I will get 3 over x squared equals 1 over d minus x squared. Okay, so I will do a radical. I will get radical 3 over x equals 1 over d minus x. Let's cross multiply. Implies radical 3d minus radical 3x equals x. I will arrange x to one side, so I will get radical 3d equals x 1 plus radical 3. Remember, I'm searching for x, so I will get x equals radical 3d over 1 plus radical 3, and I know that d is 1.5, so 1.5 over 1 plus radical 3, and I will get x equals 0.951 meter, and this is the answer. So at this point, okay, at this x, I have equilibrium for Q3. And the second part, اكيد بغض النظر عن التشارج الQ3 يمكن بلس ماينس شو قيمتها، لانه ما بين قيمتها يعني اختزلناها نحن وعم نحل. سو شو ما كانت قيمه الQ3 قد ما كانت قيمه الQ3 وشو ما كانت الساين لها، بهيدا المطرح السم للفورس رح يكون عندها على طول 0. اوكي، so in part B he asks something which is not نحن ما كتير بهمنا, but I will explain it. بقلنا كان the equilibrium be stable. What does he mean by stable equilibrium؟ يعني إذا أنا بزيحها شوي للتشارج Q3 من مطرحها, هل بترجع على equilibrium تعولة أو no؟ خلاص بتفل. I will explain it rapidly and you can deduce. So in part B نحن عنا كان بالسؤال ال Q1, this is Q1, it was positive. كان عندي ال Q2, it was positive, and Q3 كانت بيناتهم, this is Q3. I have two cases for Q3. يا ال Q3 راح تكون معي positive, يا ما ال Q3 راح تكون معي negative. Let's start first by assuming that Q3 is positive. Assume, okay? So I will assume here if Q3 is positive. If Q3 is positive, then let's draw the forces acting by 1 on 3. هلا ال 1 on 3 ال Q1 plus ال Q3 plus, so it's a repulsive force. It will be like this. This is the force exerted by 1 on 3. Okay, it's a repulsive force. Remember, when you draw the force, you draw it on the line joining the two charges. Okay, برسم على نفس الخط تاع charges. Now Q2 and Q3, if I look at them, both of them have positive signs, so they will repel each other. So if I'm going to draw the force exerted by 2 on 3, I will draw it like this. It's a repulsive force. So this is the force exerted by 2 on 3. هلا بما انه هيدا البوزيشن هو عباره عن equilibrium position for sure, F1 on 3 and F2 on 3, they are forces having equal magnitudes and opposite directions. Why? Because I have chosen X انه تكون هيك. اوكي, هيدا بهيدا الموقع بتساوي الفورسز هيك. لو انا بحيلا موقع تاني كانت ال Q3 ما كانوا رح يكونوا الفورسز بيساووا بعض. هلا الفكره انه انا اذا بزيح لي Q3 شوي يمين او شوي شمال, بما انه ال Q1 وال Q2 هن عم يعملوا repulsion لل Q3, فاذا انا بزيح ال Q3 شوي لجهه ال Q1, ال Q1 بترجع بترجعها لمطرحها, واذا انا بزيحها شوي لجهه ال Q2, ال Q2 كمان بتعمل لها repulsion بترجعها على مطرحها. So دايما التشارجز Q1 و Q2 اذا بتتحرك ل Q3 يمين او شمال بيعملوا repulsion لل Q3 وبيحاولوا يرجعوها, يبعدوها عنه, يرجعوها على المطرح اللي اجت منه. So بشكل عام هيدا بسميه stable equilibrium. هلا رح فرجيكم شو الفرق مع non stable equilibrium. نفس الحالة, okay, I have Q1 which is positive given by the question. This is Q2, which is also positive, and this is Q3, which is assumed to be negative. أنا راح أخذ الحالة الثانية. assume Q3 is negative. بهيدي الحالة لما ال Q3 is negative, there's an attraction between Q1 and Q3. So if I'm going to draw the force exerted by 1 on 3, it will be an attractive force. كمان force exerted by 2 on 3 is an attractive force. هلا على ال position X أكيد ال forces F1 on 3 plus F2 on 3 is equal to 0. We have equilibrium, everything is good, ما في أي مشكلة. بس الفكرة إذا أنا بزيح ال Q3 شوي يمين أو ال Q3 بزيحها شوي شمال، إذا أنا بزيحها شوي على الشمال ال F1 on 3 بتغلب ال F2 on 3، so ال Q1 بتعمل attraction لل Q3. اوكي، واذا بزيحها على اليمين شوي ال Q2 بتعمل attraction لل Q3 لانه الفورس F2 on 3 بتغلب الفورس اللي هي F1 on 3. Remember that the force هي it depends on KQ1. Remember that the force depends on KQ1 Q2 over distance squared. So كل ما تصغر الديستانس كل ما بتكبر الفورس. So لما أنا أقرب التشارج لعند واحدة من التشارجز بتصغر الديستانس بيناتهم، so الفورس بتكبر بهيدي الحالة. In this case إذا أنا بزيح ل Q3 شوي يمين أو شمال، so رح أنا عم بفسح مجال للتشارج تعمل لها attraction. Okay, and I will call this equilibrium an unstable equilibrium. So for part B, my answer will be yes, there is a stable equilibrium if the third bead, which is Q3, or the third charge Q3, has a positive charge. If it has a negative charge, it will be an unstable equilibrium. Okay, so yes, I will write. It's yes if the third bead has a positive charge. Okay, and this is problem 11. I will move now to the next one. I will move to problem 13, page 683. This problem says 3 charged particles are located at the corners of an equilateral triangle as shown in figure 23.13. Calculate the total electric force on the 7 microcoulomb charge. So because they don't have names, I will call them names, which helps me explain. Okay, I will call this one, this is Q1. I will call this Q2. And I will call this one Q3. Okay, in this question he required the total electric force, so the force exerted on the 7 microcoulomb charge, which is Q3 for me. Okay, so we are going to find the force exerted by 1 on 3 and the force exerted by 2 on 3 and then add them, because he's asking for the total force on Q3, which is the 7 microcoulomb charge. So our question here, he's asking for F3, which is force exerted by 1 on 3 plus force exerted by 2 on 3. So let's start. Let's start with 1 on 3. مثل العادة, first I find the magnitude. Remember the steps. The magnitude 1 on 3 it's equal to K absolute Q1. All the time the magnitude is in positive value. Absolute Q1 over Q3 over the distance between them, the distance between Q1 and Q3. Okay, so I will get K, it's 9 times 10 to the power 9. Q1 is 2 microcoulomb, so it's 2 times 10 to the power minus 6. Q3 is 7 microcoulomb, so it's 7 times 10 to the power minus 6 over the distance between them. It's 0.5. It's an equilateral triangle, so you can see here it's 0.5 meter, so no need to change to SI unit, so 0.5 squared. Calculating this, you will get 0.504 Newton. لقيت الماgnitude. بعد ما الاقي الماgnitude I draw it. Okay, let's draw it. I look at the charges. Q1 is positive, Q3 is positive. أنا عم برسم عم برسم الفورس على ال Q3. I'm drawing my forces on Q3. So الرسمة بتكون على Q3. ال Q1 positive, Q3 positive, they repel. So لما بنرسم أنا الفورce exerted by 1 on 3 برسمها على نفس الخط على ال 1 on 3 repulsive. So this is the force. I will make it smaller. So this is the force exerted by 1 on 3. Okay? هلا من بعد ما رسمتها, now I need to draw it or write it as a vector. How to write it as a vector? I have to use the geometry of the figure to write it as a vector. هلا this problem is a little bit harder from the problems that I have already solved, which were, I guess, there were 8 and 9, because هون the charges they are not forming a right angle, or they are not collinear. They're forming a different triangle or an equilateral triangle, so it needs a little bit of work. Okay, so but never mind, they are very very easy. هلا كيف بكتبها ك vector؟ like شو بعمل؟ F1 on 3 مطرحها I imagine the x or y Cartesian coordinate system. So this is the x-axis for me, or the horizontal, and this is for me the vertical. Okay, دايما نحنا بنكون عاملين given I with J. So this is I, this is J. So this is my force. This is an equilateral triangle, so for sure I have the angle here is 60. Let me take this color. So this angle here is 60. So بس أنا أعرف الانجل, I look at the force. The force can be divided into two parts. part على x axis, part على y axis. البارت اللي هو على x axis هو f1 on 3 cosine 60. البارت اللي هو على y axis هو f1 on 3 sin 60. please لما تكون تعملوا projection, الكومبوننت اللي هو adjacent مع الانجل اوكي will be cosine, والكومبوننت اللي هو تاني واحد بيكون sin. So وكمان بنتبه للإشارات. إذا أنا بدي أعمل projection, البروجكشن على x axis مع ال positive sense, والبروجكشن على y axis مع ال positive sense. So if I'm going to write it as a vector, I will write it like this: f1 on 3 equals plus, لأنه البروجكشن رح يجي مع ال positive sense, f1 on 3 cosine 60 I plus f1 on 3 sine 60 j. It's like this. Okay, I can substitute. So 0.504 cosine 60 I plus 0.504 sine 60 j. Substituting for cosine 60 and sine 60, we will get 0.252 I plus 0.436 J. So هيك كتبتها ك vector. Now I finished from working with f1 on 3. I will do the same for force exerted by 2 on 3. أول شي ببلش بالmagnitude. Okay, let's start with the magnitude. f2 on 3, it's equal to k absolute q1 q2 q3 over r squared, distance between them. It's equal to 9 times 10 to the power 9. The q2 is negative. Remove the minus sign. No need for the minus sign. You are using an absolute value. So 4 times 10 to the power minus 6. Q3 is 7, so 7 times 10 to the power minus 6. Over the distance between them, it is 0.5 squared. Calculating this, you will get 1.008 نيوتن. اوكي هلا من بعد ما جيب الماجنتيود I have to draw it. Let's draw it. برسمها على Q3. بما انه ال Q2 and Q3 they have different signs, so it will be an attractive force. An attractive force برسمها على الخط تاعو ل Q2 Q3 لعند ال Q2. So it will be like this. This is okay. So this is force exerted by 2 on 3. تنرسم على 3 لأنه هي force exerted on 3. من بعد ما رسمها هلا now I need to write it as a vector. Okay. هلا it's obvious كمان هون إنه this angle here is 60. Okay. How can you know that? Okay, everyone مثلا can use his own methods. You can say for example that this angle here is 60, it's alternating with this angle, or you can say that here for example this is a bisector, the angle is 30, so you can deduce this is 60. كل واحد بيستعمل الطريقة اللي هو بيرتاح فيها وبيلاقي الانجل بالطريقة اللي هو بيلاقيها. Okay, so I will erase this. I will erase the 30. Okay, I will keep it. So F2 on 3 is making an angle 60 with the x-axis. هلا بدي اعمل projection لإلها. أول شيء للprojection بدي انتبه للساين وللزاوية. أول شيء على x-axis الprojection positive بينما على y-axis الprojection is negative. I will draw it and then I will erase it كرمال الصورة. إذا أنا بدي أعمل projection لل F2 on 3 I will use the green color. Look, هيدا ال x component وهيدا ال y component. بعمل 90 ب 90. So this is ال x component وال y component. ال x component positive لأنه مع ال I. ال y component negative لأنه مع ال j. So دايما لما بدي أعمل projection بحط الساين. ال x component رح يطلع معي plus. ال y component رح يطلع معي minus. I will erase them. So let me write F2 on 3 as a vector. Okay. F2 on 3 it's equal to plus F2 on 3. هلا no need to do the write the plus but أنا I'm writing it لحتى أذكركم إنه دايما قبل ما تعمل projection كنت تنتبهوا إذا هي مع ال x axis بعكس ال x axis ال projection مع ال y بعكس ال y. So cosine 60 I minus F2 on 3. ال F2 on 3 هو الماجنتيود اللي بيكون على طول positive. Okay. Sine 60 J. So you will get, calculating this, you will get 0.504 I minus 0.872 J. So let's find F3, which is adding both of them. So it's F1 on 3 plus F2 on 3. It's equal to 0.756 I أنا حسبتهم already minus 0.436 J. أوكي عادي جمعت ال I مع ال I ال J مع ال J. هلا إذا بدو الماجنتيود للفورس هو مطلب I'll find the force, the total force. I will just check if he asked for the magnitude, but I usually find them because we usually ask for them in questions. So he said just find the total electric force. It did not say magnitude or vector or nothing or direction. I will find the magnitude and the direction. So if I'm finding the magnitude of F3, it's simply Fx squared plus Fy squared. It's 0.756 squared plus 0.436 squared. You will get 0.872 Newton. If I need to find the direction اللي هي الانجل مع الاكس axis اللي عملتها هيدي الفيكتور مع الاكس axis, so theta will be equal to tangent minus 1 Fy over Fx. نقسم الواي على الاكس مع الساين. Okay, so tangent minus 1 minus 0.436 over 0.756. Use your calculators to do that and you will get approximately minus 30 degrees. Okay, so let's look at F3 and the figure. هي الفورس هي resultant force لهيدول اتنين forces. هي مجموعة اتنين forces that I have already drawn them in red, which are acting, both of them are acting on Q3. So فعليا هيدول اتنين forces أنا بدي اجمعهم. I complete the parallelogram like this. I complete the parallelogram and I draw, this is in green, I draw F3, which is the force acting, the resultant force acting on Q3. إذا أنتم بتلاحظوا F3 هي تحت الإكس axis. اوكي بزاوية 30. كرمال هيك طلعت معي الانجل minus 30. It's minus 30 because it's under the x axis and not above the x axis. So that's why we have an angle minus 30. Okay, so if Q3 was to move, it will move in the same direction as F3. Okay, but this is not required for us. We're only concerned in finding the force acting on the charge.